everybody who tried, the answer was $18.90.
Remember, we changed the name of this. So I want you to change example 2 so that it says changing to standard vertex form. We kept the word completing a square as the method for equations, and we called changing to standard form the method for equations because they were slightly different. We wrote the steps down for this the other day, but this is a good review of it. Okay? What you want is the following. And this is on your formula sheet. There's our standard form. It has x minus p squared in it with the a value factored out. This is general form. And general form has ax squared plus bx plus c. That's on your formula sheet as well. So to change it to standard form, we notice that we have to find a, p, and q. And the a is going to be the same as the a in the general form. But in the standard form, the a is factored out. And sometimes we call the standard form the vertex form because the p and the q make your vertex. We also have learned that the p moves things left and right, the q moves things up and down. So in this one, we would need to factor out that -2. That would leave us with x squared, and we're still going to have a -3 on the outside. So the number, because the number is going to be part of the q, it's okay to keep the -3 outside there, but everything with the x's is going to be inside your brackets. And when I take out that -2, that's going to change my 5. Can you see that 5 was positive, but if you factor out a negative, it will now be negative. And factoring out a number, sometimes it's hard to see when it's not a perfect factor, right? How do you take a 2 out of 5? It doesn't factor perfectly. Well, factoring out is like dividing. So I could write 2.5 here, but I am going to write a fraction because you're going to find that math with fractions is a lot easier than math without fractions, which seems sort of counterintuitive. We are on page 293. Now we need a number in here, and if we put a number in here, we're going to need a number there as well. This is our goal, to have x plus or minus something inside of our bracket. And this that -5/2 is your hint. And this is a great example of if you didn't pay attention to the pattern of the hint earlier, you get stuck when you go to fractions. Okay? So let's go back and let's just off to the side here. You don't need to write these down. See if we can remember what the pattern of the hint was. If I had a plus 4x, and you FOILed out this, can you see that this would be a 2? If you had a plus 10x, the 10 would be a hint. The only way to get a 10, you would need a plus 5. If I had a minus 20x, the 20 would be a hint, and you would need a minus 10. what's the pattern in the hint? It's half. Okay? Because it's pretty hard for our brains, like in these ones, I think your brains can multiply them out and say, oh, if I did x plus 5 times x plus 5, I'd have 5x, that would make 10x. It makes sense that it's half, because we can do that mental math easily. But as soon as we get to that fraction, all of a sudden our mental math is hard, and then we get stuck. But if we recognize this pattern all along the way, half of this is really easy. And half of something is just multiplying it by half. Can you see that you would get negative 5 over 4? Why is this nicer than decimals? Well, you could have had negative 2.5, and I think you would have been pretty good at dividing negative 2.5 in half, and you would have got negative 1.25. And now you're going to run into problems if you were still in decimals. What is 1.25 times 1.25? Mental math, quick. It's not happening quick. Okay? But 5 over 4 times 5 over 4 is not hard. Can you see that that would be 25 over 16? Because 5 times 5 is 25, and 4 times 4 is 16. And so the fractions actually make our mathematics really easy. And what do I put in the other green space as a result? Okay, it's not going to be 25 over 16. Because what have I actually done? Usually, if you add something, you have to compensate and subtract the same thing. But I haven't just added 25 over 16. That 25 over 16 gets multiplied by that negative 2. So I've actually subtracted, either you can think of, right, because 2 is 2 over 1. How do you multiply fractions? Multiply the tops, multiply the bottoms. So some people will say you've subtracted 50 over 16. And some people will go, oh, the 2 and the 16 simplify. You've actually subtracted 25 over 8. So in order to compensate, I'm going to need to add 25 over 8. Now, how do you add fractions? We're going to need a common denominator, so I'm going to change my minus 3 to minus 24 over 8 plus 25 over 8. And now we've changed it to standard form. What can we find from the standard form really quickly? We know from the standard form that our vertex is 5 over 4, comma 1 over 8. Numbers are fractions. This wouldn't be a very easy one to graph as a result, but it would be possible. Okay? What did the question ask us for? It asked us for the axis of symmetry. The axis of symmetry is the dotted line around which the parabola is symmetrical. Now I drew my parabola upside down this time because my a value was negative. And I know that my vertex right here is 5 over 4, comma, negative 1/8. So my axis of symmetry, always x equals, positive 1/8, yeah. My axis of symmetry, always x equals, and it's always the x coordinate of your vertex, So our axis of symmetry will be x equals 5 over 4. Questions for practice on this one, please circle 8 and 10. Actually, I'll give you 5 minutes to try those right now, just to practice the completing the square.